In today's video, we are going to learn how to perform composite reliability or how to calculate composite reliability in structural equation modeling. Let's say you have performed your CFA and you have no option to check that, and you don't have any plugin in Amos, or the software you are using doesn't offer an option for performing of the composite reliability. This is very easy in Excel. We'll just walk through some few steps and you'll be able to get the procedure. Although you might have slightly difference in the estimates for the composite reliability in Excel and also any type of software you use, but it's reliable since they are different packages. So the first thing you need is to export your loading, that is the standardized loadings from your software. So this is what I will do. So I'll just import it and consider my factor loadings that are standardized. So this is, and you should always ensure that the item names or indicator names are always there. This will help you in the process. So this is what we have, the standardized loadings. So we can highlight this. So this is the step. The first thing is to calculate the sum of factor loadings of all items. So it means that we are supposed to take a sum of this. So you just click on the last row, equal to sum, bracket open, you highlight all your loadings and press enter. So you can label this as sum standardized loadings. So you can do it this way and you can highlight this. So the next step too is to square the sum of factor loadings. So we can do something like this, squared. So you just say squared or squared standardized loadings. Then you can highlight it. So there are two ways. You can do it this way, equal to this. You put this sign and you put 2. And when you press enter, you have 19.6249. Or simply, you can do it this way, equal to 4 times this. Then you still have the same estimates. So you can highlight this one too. The next step is to calculate the error variance for each item in the scale. So what we are supposed to do is to subtract our squared factor loadings from 1. And with this one, we are going to do it for the different items in the scale. So we have to come here and say squared loadings, and we can resize this. So I'm just going to do like this, the same procedure. Click on this, times again, then you press enter. So you can drag it to the last item to get your square loadings. But look at what they are saying here. You are supposed to get your error variance for each item, which is 1 minus squared loadings. So we are supposed to subtract these loadings, the square loadings we have highlighted here, from 1. So if you pick one item, you subtract from 1 to get the error variance. So we can do it this way, error variance. So we can just leave it this way. Then we'll say equal to 1 minus then this. So when you do this, you can drag to the last item and these are your error variances. But look at what they are saying again here. Squared sum of factor loadings. So it means that squared factor loadings, after subtracting it, this is what you get. But they are also saying that sum the error variance for each item in the scale. So it means that we need to sum this one too. So you can say sum, then error variance then you can close that. So you can highlight this one too, then you do your sum, which is equal to sum bracket open, highlight, then you have your estimates. So the last thing we are supposed to do, when I say last, it means that before we now do with the division, is to calculate the total. So with the total, we're supposed to add the squared sum of loadings and the sum of error variance. So sum, you add them together to get the total. So we have the sum here, and we have what? Sum here. But look at what they are saying here. Squared sum. So it means that we are now going to use this. So we'll say that total will be this. Squared standardized or squared loadings, that is this, plus this, that is the sum of error variance. So with this particular squared standardized loadings is the same as the squared sum of standardized loadings or factor loadings. Since we have the sum here with square, so it still represents sums standardized loadings. And this, which we know to be the sum error variance, is still the same thing. So we only need to add the squared sum of standardized loadings with the sum of error variance to get our total. So when we do this, we are going to get 20.689094. So since we have this, the next thing we are supposed to do, which is the last one, is to divide the squared factor loadings by the total. So it's just like the previous one when we were calculating the AVE, where we said we would take an average of all the squared factor loadings. But with this, you are going to divide the squared sum of loadings in the scale. So it means that if you have 20 items or indicators in a scale, you are going to use sum of these 20 by the total. So we now say composite reliability is equal to squared sum of loadings divided by what? Total. So this divided by total, and when you press enter, you have this. So let's put this into 2 decimal places. So this means that we have good composite reliability because our estimate here is 0.95. So let's try to see whether it's similar or it's just the same as the one in the software that I am using. So I'll come back to the software again, run my confirmatory factor analysis. I will import all this. So let's say factor 1, let's leave it this way, and waiting for initialization of model. Okay, so we'll go to additional outputs. We are going to see reliability. Let's check this and see. So I'll just go down there, and we have what we call reliability. So I'll just copy this and paste here, reduce to 2 decimal places, this decimal places. So this is 0.95, so it's just the same, but this coefficient W is a McDonald's omega, and this one is coefficient alpha. It means that it's a convex alpha. So it means that both the convex alpha and the McDonald's estimates are the same. So this is how we calculate composite reliability. The actual formula is there. I tried getting it in sorry. Okay. So this is the actual formula. However, it's sometimes confusing for most of us who are not statisticians or we are beginners. So with the procedure I just put in here, it can help you with the process. Thank you.